I'm back, and now we're going to be doing part 2 of the lab, which is forces and acceleration. So before we get started, let's talk about what is acceleration. So acceleration is given by the letter A, and it's defined to be the change in the speed of an object over time. So if the speed is changing, it is accelerating. And then the units are going to be meters per second, but you could put that all together and just say that it's meters per second squared. So the next part there says to describe the motion of the cart when a force is acting on it. So if we go back to the simulation here, and then now we do need to click on the values, and we do need to click on, well, at first let's not click on the speed. So we're going to take how about an adult? So let's take an adult and put them on there, and then hit the go button. Okay, how would you describe what that ore cart is doing? And then you will put that into the lab. Now it was kind of hard to tell exactly what that motion was, so this time we're going to reset the simulation. We're going to put an adult back on there, but this time we're going to click on values, and we're going to click on speed, and you see that we get a speedometer there, and we're going to click on go. And what I want you to be noticing is, do you see the readout on the speedometer? So based on what that needle was doing on this, you should be able to figure out the correct way of describing the motion of the object. Okay, now we're going to go down here to question 6. Now this is a little bit complex. How is the acceleration of the object related to the force acting on the object? Now you got a 50-50 shot here. So is the acceleration proportional? So notice it's not an equal sign. It's proportional to 1 over f, or is the acceleration proportional to f? So the question is, should the f be on the bottom part, the denominator, or should it be on the top part, the numerator? And so you have to remember the idea that like 1 divided by 1 is equal to 1. Well, that's not very difficult. But what's 1 divided by 10? So then that is going to be 0.1. So do you see that as the bottom part of the fraction is getting bigger, what's coming out of the thing is getting smaller? Okay, and so what you want to do is look at the force that's being applied, and then what is it causing the what's the acceleration doing? So this first one here, okay, so this one, if you put a large force in the bottom part of the formula, then it's going to make the acceleration get something. Now, on the other hand, if you put a large force over here, then it's going to make the acceleration get something. Okay, I don't want to give it away, but the answer is going to be either this one or it's going to be this one here. So you figure out which one makes more sense. So increase the force, see what it does to the acceleration, and then that's going to tell you whether it's this one or this one. Okay, now once you've figured that out, use the relation you just derived to answer the following. Okay, so it's off the screen here. A force causes an object to accelerate. Okay, now 7 times the force is being applied to the same object what's going to be the new acceleration. Okay, so this one, your answer is either going to be 7 times or 1/7. So you figure out what the answer is. If you apply 7 times the force, what's the new acceleration going to be in terms of the old acceleration? Okay, now let's go down to part 3 and let's take a break.